In this video, I will discuss the JEE Advanced PYQ from the topic Current Electricity. This question has appeared in the year 2020. Timestamps are given in the description box. You can watch parts of video if you are running short of time. This is the question. You can read it. Shown in the figure is a semicircular metallic strip that has thickness T and resistivity rho. Its inner radius is R1 and outer radius is R2. If a voltage V0 is applied between its two ends, the current I flows in it. In addition, it is observed that a transverse voltage delta V develops between its inner and outer surfaces due to purely kinetic effects of moving electrons. Ignore any role of the magnetic field due to the current. Then the figure is schematic and not drawn to scale. Option A, the current I is V0 into T by pi rho into ln R2 by R1. Statement B, the outer surface is at a higher voltage than the inner surface. Statement C, the outer surface at a lower voltage than the inner surface. Statement D, delta V is proportional to I square. You can pause and run this question. So the current is entering like this and coming out like this. So the current will flow like this. It will flow tangentially and come out like that. So if you take one particular strip, say of thickness dr, and the next strip, similarly the current will flow. So all these strips are in parallel because the current flowing, if you add them up, you'll get the net current. And the potential drop across each strip is the same V0. So the strips are in parallel. So the resistance of the strip, the reciprocal of the resistance will add up because they are in parallel. So you get the resistance of this one strip, which is say dr, which is small resistance because the strip is infinitesimally small, equal to rho into length of the strip, which is semicircle, it's pi into r. R is this radius from here to here. This R. Pi into L divided by area of the, so this is the cross section area. So here, this thing has got a, so if you look at the cross section, it's of length dr, and here there is a thickness T. So this cross section area is T into dr. Rho L by A, actually it is reciprocal. No, this is fine. Dr is this one, rho L by A. Okay, so what we need is 1 by dr because to get the total distance, we have to add the reciprocal of resistances. So T by rho pi into dr by r. T is the thickness of the strip, which is uniform and constant. Rho is the resistivity, pi is a number. So the variables are r. So total resistance of this strip, that is 1 by r. It's sum of 1 by dr. Because in parallel, the reciprocal resistance will add up. So to indicate this one, so that will give me 2 by rho pi. This is ln rho between the limits. Inner radius is R1, outer radius is R2. So it's R2 by R1. And Ohm's law is V equal to I into R. So from this I'll get I equal to V into 1 by R. So if I multiply this by V, I'll get the current. into ln of R2 by R1. So statement A says the current I is actually that voltage is V0. So here the voltage should be V0. So current equal to V0 T by pi rho. So option A is true. So the current is flowing in this direction, and since this is a metallic strip in a solid, electrons are the mobile charges. So the electron will move like this. The electron here, so for example here, it's a negatively charged thing, so it will move in this opposite direction of the current. So it has got a mass, so there will be a centrifugal force, which is mv square by the radius of the path, which is r. So there will be outward. So balance this, there has to be a inward force. So there will be a positive charge accumulation here, and negative charge accumulation here. So the electric field is this way. The electron will get attracted towards the positive charge. So this will give an electrical force in this direction. So these two will be in balance. Force on a charge of the electric field is the charge value of the electric field. So mv square by r should be equal to the electron charge into the electric field E. Because the current is flowing in a tangential direction, so the electron here has to maintain this radius r. So for that, the centrifugal force should be balanced with the electrical force. So from this I get the electric field E as m by E v square by r, where v is the velocity of the electron. So option B says the outer surface is at higher voltage. So the positive plate is at higher potential. So the outer surface is at a lower voltage. So option C is true, B is false. On option D, you have to find delta V. Delta V is the potential drop from here to here. It is integral A to dr. The electric field is this thing. So electric field is m by E v square by r dr. So from r1 to r2. So if you assume this velocity is not a function of r, then m and e are constant will come out, so v square also will come out. So this will be into ln of r2 by r1. So if this assumption is true, then v square will come out, and if velocity is moved, the current will be moved. So current is proportional to the velocity, because current is rate of flow of charge. So this is proportional to v square. Other things are constant, and v square is proportional to I square. So the potential difference in the transverse direction is proportional to I square. So option D is also true. So this is what I explained here. So the currents in parallels in the strips will get added up because they are in parallel. Since they are in parallel, the reciprocal resistance will add up. So resistance of one strip is dr, which is rho into length of the strip, which is pi r, semicircle, and area of rotational area of the strip is dr into the thickness of the strip, which is T. So T, pi, rho are constant, and dr by r, integrate will get ln r, between the limits will become r2 by r1. So Ohm's law I equal to V by r. So V naught into 1 by r is this one. So option A is true. And since the current is flowing in this direction, electron which is negligible will flow in this direction. So there will be centrifugal force mv square by r that should be balanced by electrical force downwards. So on the inner radius there has to be positive charge accumulation. Outer radius there has to be a negative charge. Only then the electron will get attracted towards the center, which will balance the centrifugal force outwards. So in this balance condition, mv square by r equal to E into the electric field, which could be a function of r. So from here I get the electric field as m by E into v square by r. And if you make the assumption that velocity is not a function of r, then it will come out of the integral sign, and we get the result that the potential drop in the transverse direction is proportional to v square. And if the velocity is more, means current is more, because current is rate of flow of charge. So from that, delta V should be proportional to the I square. So option D is true, and positive place the higher potential. So the outer surface is at lower potential. So option C is true. B is false. So I don't think this is a good question to be asked in an exam, because some assumptions have to be made.